So this is where we stopped yesterday. 2x plus 1 times 5x cubed minus 8x squared minus 17x plus 12. We decided yesterday that we couldn't factor that we can't factor that using our factoring methods, can we? So what must we use again? I can't talk. Rational root theorem. Yes, we love it. So what's my constant term of this new polynomial? 12. So I'm going to list factors of 12. Read them off to me.
1, 2, 3, 4, 6, 12.
Very good. There's my factors of 12. What's my leading coefficient that I now need to list factors of? 5, since we're using that new polynomial. Luckily, it's just 1 and 5.
What if we didn't have the problem in standard form and like the exponent for 8 was higher than the exponent for 5?
You would have to recognize that and use that as your leading coefficient.
So then we would use 8?
Yes.
Okay.
Yep. It's a very good question. If it wasn't in standard form already, and say you had 5x cubed minus 8x to the 4th, you'd have to use negative 8 as your leading coefficient. Okay? Any other questions? Okay, now I need to put all my factors of 12 over all my factors of 5. So I got 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, and 12 over 1. That's all my factors of my constant term over one factor of my leading coefficient. Now what do I need to do? Put all of them over 5 now. Is that one already listed where I need to cross it off? Nope, I can leave it. Plus or minus 2 over 5. Plus or minus 3 over 5. Plus or minus 4 over 5. Plus or minus 6 over 5. Plus or minus 12 over 5. Are any of those multiples where I need to take them out? Nope. Here's my list of possible solutions for this new polynomial. We're going to go ahead and use the graph again, the graph of this new polynomial, to see what our possible factors might be. Okay? So here's the graph of this new polynomial. Where are my solutions again? Where my graph touches or crosses the x-axis. So that'd be here, here, and here, correct? So let's look at the first one. What value does that look like it might be?
Negative 1/2.
Negative 1.5. So what would that be as a fraction? 3 over 2, right? Is negative 3/2 on my list of possible solutions? It is not. So do you think I'm going to test negative 3/2? No. It's crossing between negative 1 and 2, correct? Right there, between negative 1 and negative 2. Is there any number on my list of possible solutions that looks like it might be between negative 1 and negative 2? Do what? Negative 1. But it would be closer to that or to that tick mark, wouldn't it? It'd be closer if it was negative 1. I'm not seeing any that would necessarily be right in the middle of negative 1 and 2. So let's skip this one for now. Okay? We'll come back to it if we need to. Let's look at this next one. What does that value look like it might be? Positive 1/2. Is 1/2 on my list of possible values? No. Is there anything that looks close to being positive 1/2? 3 over 5? 2/5 and 3/5, right? Okay, so we might be onto something here. Let's go look at this graph again. Does this look like it would be closer to 2/5 or closer to 3/5? Does it look like it's a little less than half or a little more than half? 3/5, right? I'd say it's a little more than half, way between 0 and 1, right? So let's test 3/5 out. Does everyone see how we kind of broke that down? So let's test 3/5. Using our synthetic division. So I'm using 5, -8, -17, and 12. Bring my 5 down. It's 3/5 times 5. 3. -8 plus 3. -5. 3/5 times -5. -3. Everyone with me? -17 plus -3. -20. 3/5 times -20. -12. What's 12 plus -12? Is 3/5 a factor? Yep, my remainder is 0. So I know 3/5 is a factor. Don't forget about your 2x plus 1 though. Still got to have my 2x plus 1. How can I represent 3/5 as a factor? X plus 3/5, x minus 3/5. X minus 3/5. And then what goes in this next set of parentheses?
5x squared minus 5x minus 1.
Everyone okay with that? Any questions? Okay, I'm breaking it down further and further and further. Very good. In this new polynomial, in this set of parentheses, I've got a GCF of 5. Does everyone see that? So let's factor out that 5. Five times what would give me 5x squared? X squared. 5 times what would give me -5x? Negative x. 5 times -4 would give me -20. Everyone okay with that? Okay, yesterday I factored out a 2, didn't I? What did I do with that 2 so I didn't lose it? I distributed it through that binomial. So let's do the same thing with this 5, distribute it through this binomial. So I still have 2x plus 1. What's 5 times x? 5x. 5 times -3/5 is -3. And then I have x squared minus x minus 4. All right, we're getting places. We're getting there. Let's look at our new polynomial now. X squared minus x minus 4. Let's see if we can factor it. Are there two numbers that multiply to give me -4 and add to give me -1? Are there? There are not, are there? So what do you think I might have to do?
Another thing?
You could do the rational root theorem again, but we don't have to. This is a quadratic equation. Quadratic expression, right? Because the highest degree is 2. So it's a quadratic. Does anyone have any ideas what I might be able to do besides using the rational root theorem? We've talked about it before in the first semester, so my other hours didn't remember either. Do you guys remember the quadratic formula? Okay. It's got a square root in it, yep.
Isn't it like b squared?
There's a b squared in it, yep. So, starts off as the opposite of b. You may want to write this down. This is our quadratic formula. Plus or minus. Here's where the square root is. Square root of b squared minus 4ac all over 2a. There's my quadratic formula. Since this is a quadratic and I can't factor it, I can use my quadratic formula to get my solutions for this polynomial. Okay? So it's nice because you don't have to use the rational root theorem again. Like I said, you could if you wanted to, but we don't have to.
On the other ones, could you use this?
I don't think we could have on the other ones.
Instead of doing it the same thing?
No, because the other ones weren't quadratics. 5x to the third, the degree is 3, right? You can only use the quadratic formula if it's a quadratic expression. Does that make sense? And I couldn't do it at the first because it was 10x to the fourth. That's not a quadratic either. And on my first example, when we used the rational root theorem the first time, when we got a quadratic, we were able to just factor it. So we didn't need to use it. Okay? So, in this polynomial, what's my a value? What's my number in front of x squared? 1. What's my b value? -1. And my c value? -4. Does everyone see where I'm getting a, b, and c? It's just the coefficients of that polynomial. 1, -1, -4. So now I can plug these into my quadratic formula. So the opposite of b, what's the opposite of -1? 1 plus or minus square root of b squared. What's -1 squared? -1 times -1. 1 minus 4 times my a value, which is 1, times c, which is -4. All over 2 times a. What's 2 times 1? 2. Everyone good with that so far? Plugging into my quadratic formula. We all taking notes and paying attention? Okay, now let's work this out. What's -4 times 1? -4. -4 times -4. Positive 16 all over 2. What's 1 plus 16? 17 over 2. So here is 2 of my solutions. Can I take the square root of 17 and get a nice whole number? No. Can it be simplified any? No. So one of my solutions is 1 plus square root of 17 over 2. 1 minus square root of 17 over 2. There's 2 of my solutions. And to get my other solutions, I can take my other 2 factors up here and set them equal to 0 and solve for x. So 2x plus 1 equals 0. 3x minus 5 equals 0. Is that 3x? No, it's 5x minus 3. And solve those for x. That's my first step on the first one. Subtract 1. Next step. Divide by 2. So x equals -1/2. There's another one of my solutions. First step on this next one. Add 3. We're almost done, guys. Last step. Divide by 5. On the left-hand side, those are my 4 real solutions of my polynomial. And I'm now done with this problem. Any questions? Does everyone see how we just kept kind of breaking it down? Like I said yesterday, the rational root theorem is just technically another way to factor if we can't factor using our other methods. So we just keep breaking it down until it's all the way to its factored form. Then I set all my factors equal to 0 and solve. Okay? On your assignment, you're not going to get any with the leading coefficient of 10. Okay? It'll all be less than 10. Okay. Any questions about the rational root theorem before we move on? Am I good to move on? Here's our assignment.
So, on the book page, will it have the graph on there?
You're not going to have near as many factors as that one example, so you can test them using synthetic division. Okay? Notice this is 25 through 37 odds. It's only about 7 problems. Okay? This will be due on Tuesday, February 9th. I feel like that's a decent amount of time to get this done. You have the rest of the class period to work on it. You'll have Monday evening to work on it, as well as Tuesday evening. Okay? So this will be due Tuesday the 9th on Canvas. So get that assignment written down. I'll project the book page up onto the board for us.
I'm going to take a picture of it
Go for it.
because I don't feel like we're
Does anyone have any questions before I end my recording? We good? As always, if you like the video, hit that thumbs up button. Subscribe to my channel if you like this content. I'll keep giving you more content like this. Okay? Subscribe. Peace out.